Hello and welcome. I'm so glad you're here tonight. Wherever you are, whatever kind of day you've had, this is your time to rest. There's nothing you need to do. You don't need to watch. Just listen. No tasks waiting. No problems to solve. Just your breath, slowing gently, and one of the most mysterious stories the universe has to offer. Tonight's tale begins. Tonight, we're going to explore black holes. Now, before you think this might be unsettling, let me assure you, black holes are not monsters. They are simply places where the universe plays by different rules. Places where time slows down, where space bends, where the ordinary becomes extraordinary. And there is something strangely peaceful about them. Think about it. A black hole is the quietest place in the universe. No light escapes, no sound, just stillness. Absolute, complete stillness. So let your body settle, let your shoulders relax, and let me take you on a journey to the darkest and most fascinating corners of the cosmos. A black hole is a place where gravity has won completely. This is the simplest way to understand what a black hole is. Everything in the universe has gravity. You have gravity. The earth has gravity. The sun has gravity. Gravity pulls things together. It's why you stay on the ground. It's why the earth orbits the sun. It's why galaxies hold their shape. But normally, other forces push back against gravity. The pressure inside a star pushes outward. The solid structure of a planet resists compression. There's a balance, but in a black hole, gravity has overwhelmed everything else. Matter has been crushed down into an infinitely small point, and the gravity around that point is so strong that nothing, absolutely nothing, can escape. Not matter, not light, not even time itself moves the same way near a black hole. The idea of black holes is older than you might think. In 1783, an English clergyman named John Michel wondered about something. He knew that light had a speed, and he knew that gravity could affect moving objects. So he asked a question. What if a star were so massive, so dense, that its gravity could trap light itself? He called these hypothetical objects dark stars. He never knew if they existed, but he imagined them. Over 200 years before we found proof, sometimes the wildest ideas turn out to be true. Einstein's theory of relativity predicted black holes. In 1915, Albert Einstein published his general theory of relativity. It described gravity not as a force, but as a bending of space and time. Massive objects curve the fabric of the universe around them. Other objects follow those curves. That's why planets orbit stars. They're following the curved paths in space-time. Shortly after Einstein published his theory, a German physicist named Karl Schwarzschild found a solution to Einstein's equations. While serving in World War I on the Eastern Front, he calculated what would happen if all the mass of an object were compressed into a single point. The answer was startling. Space-time would curve so dramatically that it would create a boundary, a point of no return. Anything crossing that boundary would be lost forever. We now call this boundary the event horizon. Schwarzschild did not live to see black holes confirmed. He died just months after his discovery. But his mathematics lives on. Every time we study a black hole, we use his equations. The term black hole was coined in 1967. For decades, scientists called these objects many things: frozen stars, collapsed stars, dark stars. But in 1967, the physicist John Wheeler used a simpler term during a lecture: black hole. It stuck. Sometimes the best ideas are the simplest ones. A hole that is black, a place where light goes in and never comes out. The name captures something essential: the absence, the mystery, the void. Nothing can escape a black hole once it crosses the event horizon. This is worth repeating. Once you cross the event horizon, there is no coming back. Not because there's a wall, not because there's a force pushing you in, but because all paths, every possible direction you could travel, lead inward. Even if you had an infinitely powerful rocket, even if you tried to fly straight up, the curvature of space-time means that up now points toward the center. All roads lead to the singularity. It's not a trap in the ordinary sense. It's a change in the geometry of reality itself. The event horizon is not a physical surface. You might imagine the edge of a black hole as a wall or a membrane, something you would feel as you crossed it. But it's not like that. The event horizon is an invisible boundary, a line in space. If you were falling into a large black hole, you might not even notice the moment you crossed it. There would be no flash of light, no sudden change. You would simply cross a threshold, beyond which your fate was sealed. The universe would continue around you, but you could never return to share what you saw. At the center of a black hole is a singularity. This is where all the mass ends up, a point of infinite density. Our mathematics breaks down at the singularity. Our physics cannot describe it. We don't truly know what happens there. Perhaps space and time themselves cease to exist. Perhaps something else entirely takes over. The singularity is the ultimate mystery, hidden behind the event horizon, forever beyond our reach. Black holes come in different sizes. There is not just one type of black hole. They range from the relatively small to the incomprehensibly massive. The smallest are stellar black holes, formed from collapsed stars. They might be just a few miles across, but they contain the mass of several suns. Imagine that. All the mass of multiple stars crushed into a space smaller than a city. Stellar black holes form when massive stars die. Throughout its life, a star is a battleground. Gravity tries to crush it inward. Nuclear fusion in the core pushes outward. For millions or billions of years, these forces balance. The star shines, but eventually the fuel runs out. Fusion stops, and gravity wins. The star collapses. In less than a second, the core implodes. If the star was massive enough, nothing can stop the collapse. Not the pressure of electrons, not the pressure of neutrons. The matter falls inward, past every limit, until it becomes a black hole. The outer layers of the star explode outward in a supernova, one of the brightest events in the universe. But at the center, darkness remains. A black hole is born. Let's pause here for a moment. Take a breath. We've traveled far already, from the first imaginings of dark stars to the violent birth of black holes in dying suns. There's no rush to continue. The black holes will wait. They have nothing but time. In fact, they have all the time in the universe. Literally. When you're ready, let's drift deeper. Supermassive black holes are the giants of the universe, while stellar black holes contain a few times the mass of our sun. Supermassive black holes contain millions, or even billions of solar masses. Let that sink in. Billions of suns worth of mass in a single black hole. These monsters sit at the centers of galaxies. Almost every large galaxy has one, including our own. There is a supermassive black hole at the center of the Milky Way. It's called Sagittarius, a star. It contains about 4 million times the mass of our sun. It sits 26,000 light years away from Earth, far enough that we're perfectly safe. But it's there, at the heart of our galaxy, a dark anchor around which billions of stars orbit, including our own sun. We have seen the shadow of a black hole. In 2019, scientists released the first image of a black hole. It was the supermassive black hole at the center of a galaxy called M87. 55 million light years away. The image showed a bright ring of glowing gas surrounding a dark circle. That dark circle was the shadow of the black hole, the event horizon, the point of no return. It took years of work, telescopes around the world working together, combining their data to create a single image. And when it was released, the world saw a black hole for the first time. It looked exactly like the equations predicted. Einstein was right. In 2022, we saw our own black hole. The same team released an image of Sagittarius A star, the black hole at the center of our galaxy. It was harder to photograph because it's smaller than the one in M87. The gas around it moves faster. The image changes minute by minute, but they did it. A glowing ring, a dark center, the heart of our home galaxy. Black holes are not cosmic vacuum cleaners. This is a common misconception. People imagine black holes sucking everything toward them, reaching out and pulling in helpless victims. But that's not how it works. A black hole's gravity is strong, but only when you get close, from far away. A black hole has the same gravitational pull as any other object of the same mass. If our sun became a black hole, which it never will, the Earth would continue orbiting normally. We wouldn't be sucked in. The gravity at our distance would be exactly the same. Black holes are only dangerous if you get too close, and the nearest one is thousands of light years away. We are perfectly safe. Time slows down near a black hole. This is one of the strangest consequences of relativity. The stronger the gravity, the slower time passes near the event horizon of a black hole. time nearly stops. If you watch someone falling toward a black hole, you would see them slow down. They would appear to freeze at the event horizon, growing dimmer and redder, but never quite crossing. From your perspective, they would take forever to fall in, but from their perspective, they would cross the horizon in an instant. And time is relative. It depends on where you are, and near a black hole, time becomes very strange indeed. This effect is called gravitational time dilation. It's not science fiction, it's measurable. Even the gravity of Earth causes time dilation. Clocks on GPS satellites tick slightly faster than clocks on the ground. The difference is tiny, microseconds per day, but it's real. Near a black hole, the effect would be enormous. You could spend an hour near a black hole and return to find that years had passed elsewhere. Black holes are time machines. Of a sort, black holes can spin. When a star collapses, its rotation speeds up, like a figure skater pulling in their arms. Conservation of angular momentum. The collapsed core spins faster and faster, and a spinning black hole is different from a stationary one. It drags space-time around with it, creating a vortex, a whirlpool in the fabric of reality. A spinning black hole has a region called the ergosphere. This is a zone outside the event horizon, where space-time is being dragged so fast that nothing can stand still. You would be forced to rotate with the black hole, even if you used all the power in the universe to resist. But here's the interesting part. You could still escape the ergosphere. Unlike the event horizon, the ergosphere is not a point of no return, and theoretically, you could extract energy from a spinning black hole by entering the ergosphere. The universe is stranger than fiction. Some black holes have jets. Not everything that approaches a black hole falls in. Some material gets caught in orbit, forming a swirling disk around the black hole, an accretion disk. This disk heats up to millions of degrees. It glows with intense radiation, and sometimes material is flung outward in enormous jets. These jets can stretch for thousands of light years, blasting energy into intergalactic space, powered by a black hole, the darkest object in the universe, creating some of the brightest phenomena we've ever seen. The contrast is remarkable. Black holes themselves emit no light, but the material around them can outshine entire galaxies. These are called quasars, quasi-stellar objects. They're so bright, they were first mistaken for stars, but they're actually distant galaxies with supermassive black holes devouring matter at their centers. The brightest objects in the universe, powered by the darkest. There's something poetic in that. Black holes might connect to other places. This is speculation. We have no proof, but the mathematics allows for something called a wormhole, a tunnel through space-time, connecting two distant points. Some have wondered if black holes might be entrances to such tunnels. Where would they lead? Another part of our universe? Another universe entirely? We don't know. We may never know. but the possibility exists in the equations, in the mathematics of curved space-time. The universe leaves room for mystery. Let's rest here for a moment. Take a slow breath in and a slow breath out. We've explored the basics of black holes, how they form, what they look like, how they bend time and space. There's much more to discover, but there's no hurry. The universe is patient, and so are black holes. They will wait billions of years. They can wait for you. When you're ready, let's continue. Stephen Hawking discovered that black holes are not entirely black. In 1974, Hawking made a startling prediction. Black holes emit radiation. This seems impossible. If nothing can escape, how can anything come out? The answer involves quantum mechanics, the strange laws that govern the smallest scales of the universe. At the quantum level, empty space is not really empty. Pairs of particles constantly pop into existence and almost immediately annihilate each other. Virtual particles appearing and disappearing in the vacuum. But near the event horizon of a black hole, something unusual can happen. One particle might fall in, while the other escapes. The escaping particle becomes real. It carries energy away from the black hole. This is Hawking radiation. Because of Hawking radiation, black holes slowly evaporate. They lose mass over time, very slowly, incredibly slowly. A stellar black hole would take longer than the current age of the universe to lose any significant mass. We're talking about timescales beyond imagination, but eventually, given enough time, black holes will evaporate completely. They are not eternal. Even the darkest things in the universe will one day fade away. The smallest black holes evaporate fastest. The smaller a black hole, the hotter its Hawking radiation, the faster it loses mass. A tiny black hole, the mass of a mountain compressed to the size of an atom, would evaporate in a fraction of a second. It would end in a flash of radiation, a final burst of energy. Then nothing, gone, as if it had never been. Some tiny black holes might have formed in the early universe. These are called primordial black holes. In the violent first moments after the Big Bang, matter was compressed so intensely that tiny regions might have collapsed into black holes. Some of these might still exist today, wandering through the cosmos, invisible and alone. We've never found one, but they could be out there. The universe is full of things we haven't seen yet. Black holes preserve information. This might sound strange. What information? Everything that falls into a black hole carries information about what it was, its mass, its charge, its quantum state. For decades, scientists wondered what happened to this information. Was it destroyed? Was it lost forever? Losing information would violate fundamental laws of physics. This was called the black hole information paradox. Hawking initially believed the information was lost, but later changed his mind. Most physicists now believe information is preserved somehow, perhaps encoded in the Hawking radiation, perhaps stored on the event horizon. The debate continues. The event horizon might be a hologram. This is one of the strangest ideas in modern physics. Some scientists believe that all the information about what falls into a black hole is encoded on the two-dimensional surface of the event horizon, like a hologram, a three-dimensional reality stored on a two-dimensional surface. And some have extended this idea further. What if our entire universe is like this? What if everything we experience is a projection from information stored on a distant boundary? The holographic principle. Black holes have led us to question the nature of reality itself. Let me share something beautiful with you. The math that describes black holes is the same math that describes the beginning of the universe. The Big Bang appears in our equations as a singularity, a point of infinite density, just like the singularity at the center of a black hole. Some have wondered if they're connected. Could our universe have been born from a black hole in another universe? Could black holes in our universe give birth to new universes? We don't know, but the mathematics rhymes. The end of a star and the beginning of everything, described by the same equations. There's a deep symmetry there. Black holes might be the most common stellar remnants. When we look up at the night sky, we see stars. But for every star shining, there might be many more that have already died. Some became white dwarfs, slowly cooling. Some became neutron stars, spinning rapidly. And many became black holes, silent, invisible, scattered throughout the galaxy. Some estimates suggest there could be hundreds of millions of black holes in the Milky Way alone. Most of them solitary, drifting through space, never interacting with anything, never being seen, a hidden population. Black holes can merge. When two black holes orbit each other, they slowly spiral inward. They lose energy by emitting gravitational waves, ripples in space-time itself. Over millions of years, they get closer and closer until finally they merge to become one, a larger black hole. The merger is violent. More energy is released than all the stars in the universe combined in that moment, but it's released as gravitational waves, not light. The universe shakes, but silently. We have detected gravitational waves from black hole mergers. In 2015, the LIGO Observatory detected gravitational waves for the first time. The signal came from two black holes merging 1.3 billion light years away. The waves had been traveling for over 1 billion years. When they finally reached Earth, they stretched and compressed our planet by less than the width of a proton. But we detected them. It was one of the greatest scientific achievements in history. Einstein predicted gravitational waves a century earlier. He didn't think we'd ever be able to detect them, but we did. The sound of black holes merging has a name. Scientists converted the gravitational wave signal into sound. It's called a chirp, a rising tone, getting higher and faster. As the black holes spiral closer, the gravitational waves increase in frequency. Then suddenly, the sound stops. The merger is complete. Two black holes have become one. If you listen to the recording, it sounds like a brief whistle or a bird chirping, the sound of the universe itself vibrating. Neutron stars can become black holes. A neutron star is what remains when a moderately massive star dies. It's incredibly dense. A teaspoon would weigh billions of tons, but it's not quite dense enough to be a black hole. The pressure of neutrons holds it up. But if a neutron star gains more mass from a companion star or from merging with another neutron star, it can cross the threshold. The neutron pressure fails and it collapses into a black hole. One more stellar corpse joining the dark population. We've never seen anything survive crossing an event horizon. This might seem obvious. Nothing can escape, so of course, nothing survives. But what we mean is, we've never seen any signal from anything that crossed. The moment something crosses the event horizon, it becomes invisible to the outside universe. Whatever happens inside stays inside. The ultimate privacy. Let's pause again. Let your body relax a little deeper. We've covered a lot of ground. The strange mathematics of black holes, Hawking radiation, gravitational waves, the chirp of merging black holes. These are some of the most profound discoveries humanity has ever made, and you're learning about them as you drift towards sleep. There's no need to remember every detail. Just let the ideas wash over you. Like waves on a shore, when you're ready, we'll continue. The largest black holes are almost unimaginably massive. There are black holes with masses of tens of billions of suns. The largest one we've found, called TON 618, might contain 66 billion solar masses. Its event horizon is larger than our entire solar system. If you placed it where our sun is, its edge would extend past all the planets, past Neptune, past Pluto, into the distant reaches of the solar system, a void larger than everything we know. These ultramassive black holes grew over billions of years. They started smaller, perhaps as stellar black holes, perhaps as something else, and over cosmic time, they consumed gas, stars, other black holes, growing and growing, patient, relentless, dark. Some supermassive black holes existed when the universe was very young. This is a puzzle. We've found quasars from when the universe was less than 1 billion years old, powered by black holes of billions of solar masses. How did they get so big so fast? 1 billion years seems like a long time, but for a black hole to grow that large, it would need to consume matter constantly, at the maximum possible rate, without pause. Some scientists think these black holes had a head start. Perhaps they formed from the direct collapse of massive gas clouds, skipping the stellar phase entirely. We're still figuring it out. The nearest known black hole is about 1,500 light-years away. It's called Gaia BH1, discovered in 2022, a stellar black hole, about 10 times the mass of the Sun. It orbits with a normal star, a binary system, but the black hole is quiet. not consuming its companion, just drifting in its orbit, silent. There may be closer ones. We just haven't found them yet. Black holes don't suck. I mentioned this before, but it's worth saying again. Black holes have gravity, just like everything else. They don't reach out and grab things. They don't pull harder than their mass warrants. From a safe distance, a black hole is no more dangerous than any other object of the same mass. The danger only comes when you get close, very close. If you fell into a stellar black hole, you would be spaghettified. Yes, that's the technical term, spaghettification. Because the gravity at your feet would be so much stronger than the gravity at your head. You would be stretched, pulled longer and longer, thinner and thinner, like spaghetti. It would not be pleasant, but it would be fast. In a stellar black hole, spaghettification would happen before you even cross the event horizon. But in a supermassive black hole, you might survive the crossing because supermassive black holes are so large, the event horizon is far from the center. The gravity at the horizon is actually gentler. You could cross without being torn apart, at least not right away. You would have some time inside to see what no one has ever seen before eventually reaching the singularity. What would you see? No one knows. Inside a black hole, the roles of space and time might reverse. This is one of the strangest predictions. Outside the black hole, you can move freely in space, but you can only move forward in time. Inside the black hole, the singularity is not a place in space. It's a moment in time, your future. No matter which direction you move in space, you're moving toward that moment. The singularity is not somewhere you can avoid. It's someone you cannot escape. Black holes might contain entire universes. Some physicists have speculated that the singularity might not be a point. Perhaps the matter falling in emerges elsewhere, creating a new Big Bang, a new universe. We might be living inside a black hole right now, from the perspective of some larger universe. It's speculation, wild speculation, but the math doesn't forbid it. Black holes have no hair. This is a famous phrase in physics. It means that black holes are surprisingly simple. No matter how complex the object that fell in, the black hole only remembers 3 things: mass, charge, spin. That's it. A black hole formed from a collapsing star looks exactly like one formed from a collapsing planet. If they have the same mass, charge, and spin, all other information seems to be erased or hidden. This is the no hair theorem. Black holes are bald, but recent discoveries suggest black holes might have some hair after all. Very subtle differences encoded in their gravitational fields. The research is ongoing. Black holes continue to surprise us. Black holes can have electric charge. If a black hole forms from matter with a net electric charge, the black hole keeps that charge. A charged black hole is called a Reissner-Nordström black hole, or, if it's also spinning, a Kerr-Newman black hole. But most black holes in nature are probably neutral because the matter that forms them is usually neutral overall. Still, charged black holes are interesting mathematically. They have different properties, different structures. The universe of black holes is more varied than you might think. Some black holes might be ancient. The oldest black holes formed from the first stars. The first stars were different from modern stars, larger, hotter, living fast, and dying young. When they died, they left behind black holes. These first black holes might have been the seeds of the supermassive black holes we see today. Growing over billions of years, some of them are still there, at the hearts of ancient galaxies, older than the Earth, older than the Sun, almost as old as time itself. Black holes don't live forever. Thanks to Hawking radiation, even black holes eventually die. But the timescales are staggering. A stellar black hole would take about 10 to the power of 67 years to evaporate. That's a 1 followed by 67 zeros, far longer than the current age of the universe, which is only about 14 billion years. A supermassive black hole would take even longer, 10 to the power of 100 years, a googol years. These are numbers beyond human comprehension, but they're not infinity. Eventually, in the unimaginably distant future, the last black hole will evaporate, and then true darkness. The far future of the universe belongs to black holes. Long after the stars have burned out, long after the galaxies have faded, black holes will remain, the last structures in a dying universe, slowly evaporating. One by one, the universe will grow cold, empty, dark, and eventually, even the black holes will be gone. This is called the heat death of the universe. It won't happen for an almost infinite time, but it will happen. Everything ends, even black holes. But let's not dwell on endings tonight. Let's return to the wonder. Black holes are laboratories for extreme physics. We can't recreate the conditions near a black hole on Earth. The gravity is too strong. The energy is too high. But by studying black holes, we learn about physics at its limits, general relativity, quantum mechanics, thermodynamics. All of these come together at a black hole. Black holes are where our theories are tested, where new physics might be discovered. They're not just cosmic curiosities. They're keys to understanding the universe. The Event Horizon Telescope continues to study black holes. The same collaboration that gave us the first black hole image is still working. They're making sharper images, studying more black holes, looking for new phenomena. Every year, we learn more. The age of black hole astronomy has only just begun. Gravitational wave detectors are finding more mergers. LIGO and Virgo have detected dozens of black hole mergers. Each one teaches us something new about how black holes form, how they grow, how they find each other across the void. And new detectors are being planned, more sensitive, able to hear fainter whispers from the cosmos. The universe is singing. and we're learning to listen. Black holes challenge our understanding. Every time we think we understand them, a new puzzle emerges. The information paradox. The origin of supermassive black holes. The nature of the singularity. We don't have all the answers. We may never have all the answers, but that's okay. Mystery is part of the universe, part of what makes it beautiful. Black holes remind us how much we have yet to learn. And yet, we have learned so much. 100 years ago, black holes were just theoretical curiosities. 50 years ago, we weren't sure they existed. Today, we have photographs. We have recordings of their collisions. We understand their physics in remarkable detail. In just a few generations, we went from imagining dark stars to seeing them. That is an incredible achievement. You are living in an age of discovery. The things we're learning about black holes would have been science fiction a generation ago. And the things we'll learn in the next generation, we can barely imagine. You are part of this story just by wondering, just by asking questions, just by lying here, listening to the mysteries of the cosmos. Let's rest now. We've traveled far, from the first dreams of dark stars to the latest images from the Event Horizon Telescope, from the birth of black holes in supernovae to their slow death through Hawking radiation, from the chirp of merging black holes to the silence of the singularity. Black holes are strange. Black holes are wonderful. Black holes are real. And the universe is more mysterious, more beautiful, more surprising because they exist. As you drift towards sleep, think of the black hole at the center of our galaxy, 26,000 light years away, 4 million times the mass of the sun. It's there right now, silent, dark, anchoring the stars, including our sun, including you. You're connected to it through gravity, through space-time, through the fabric of the universe itself, and far beyond our galaxy. In every direction, more black holes at the centers of galaxies, drifting between stars, merging in the dark, a universe full of hidden darkness and hidden light. Sleep now. Let the black holes keep their vigil. They have all the time in the universe. They will still be there when you wake. Silent, patient, waiting. The universe is vast, and you are part of it. A brief flicker of consciousness in a cosmos full of wonders that makes this moment precious, this quiet moment, this time of rest. Dream of the darkness between stars. Dream of gravity bending light. Dream of time slowing down as you drift closer and closer to sleep. Good night. Rest well, and may your dreams be as deep as the mysteries of the universe. Let me share a few more wonders with you as you drift in that gentle space between waking and sleeping. Black holes bend light in beautiful ways. This effect is called gravitational lensing. When light passes near a massive object, its path curves. Near a black hole, the curving is extreme. Light can be bent so much that it wraps around the black hole. You could see the back of your own head, light from behind you, curving around the black hole and reaching your eyes from the front. Strange, wonderful, real. Astronomers use gravitational lensing to study distant galaxies. Sometimes a black hole or galaxy sits between us and a more distant object. The gravity acts like a lens, magnifying the distant light, bending it into rings and arcs. We can see things that would otherwise be too far away, too faint. Black holes help us see more of the universe, even as they hide themselves. There is a ring of light around every black hole. It's called the photon sphere. At exactly the right distance from a black hole, light can orbit, photons traveling in circles, neither falling in nor escaping, perfectly balanced on the edge of darkness. This ring is unstable. The smallest nudge sends the light falling in or flying away, but for a moment, light dances on the edge. If you could hover near a black hole and look at the photon sphere, you would see a bright ring. All the light that has ever grazed that distance, circling endlessly, an accumulation of ancient light. Black holes grow when they eat. When matter falls toward a black hole, it doesn't fall straight in, it spirals. Conservation of angular momentum. The same reason water spirals down a drain. This creates an accretion disk, a swirling disk of gas and dust, orbiting the black hole. The accretion disk is hot, incredibly hot. As material spirals inward, it moves faster and faster. Particles collide. Friction heats everything up. The inner parts of the disk can reach millions of degrees. They glow with X-rays, ultraviolet light, visible light. This is how we detect many black holes, not by seeing the black hole itself, but by seeing the glowing disk around it. Some black holes are quiet. They sit in space, not consuming anything. No accretion disk, no jets, no radiation, just a dark sphere of nothingness, drifting through the void. These are the hardest to find. If we detect them by their gravity, by the way they affect things around them, a star wobbling in its orbit, light bending around empty space, subtle clues. The black hole, Cygnus X1, was one of the first discovered. In the constellation Cygnus, the Swan, a blue supergiant star, orbits an invisible companion. Gas streams from the star toward the companion. The gas spirals inward, heats up, emits X-rays. We can't see the black hole, but we see what it does to the star. Stephen Hawking once bet against Cygnus X1 being a black hole. He bet his friend Kip Thorne, if Cygnus X1 wasn't a black hole, Hawking would win a magazine subscription. If it was a black hole, Thorne would win. Hawking lost, and he was happy to lose, because the existence of black holes was more exciting than any bet. Kip Thorne went on to help create the movie Interstellar. He worked with the filmmakers to make the black hole in the film scientifically accurate. The result was stunning. A glowing disk of light, bent and warped by gravity, a dark shadow at the center. When the movie came out, scientists realized the simulation had taught them something new. The way the accretion disk appears from different angles led to new research papers, art and science, learning from each other. The black hole in Interstellar is called Gargantua, a fictional supermassive black hole. In the movie, astronauts travel near it, experience time dilation. 1 hour near the black hole equals 7 years on Earth. This is scientifically plausible. Near a spinning black hole, time dilation can be extreme. The movie took creative liberties, but it was grounded in real physics. Speaking of time, let's rest in this moment. Time is moving normally for you now. 1 second follows another. Your breath rises and falls, but near a black hole, this moment would stretch. Your single breath, lasting hours, days, from the perspective of someone far away. Time is not fixed. It flows differently depending on where you are. Right now, in this bed, in this room, time is flowing at its own pace, and that pace is perfect for rest. Let me tell you about frame dragging. A spinning black hole drags space-time around with it. Imagine space as a fluid. The spinning black hole is like a whisk, stirring the fluid around it. Everything near the black hole gets caught in this rotation. Even if you tried to stay still, you would be pulled along. Space itself is moving. This effect is real. It's been measured around Earth, though the effect is tiny. Around a black hole, it's dramatic. There's a region around a spinning black hole called the ergosphere. Inside the ergosphere, nothing can remain stationary. Everything must rotate with the black hole, but the ergosphere is outside the event horizon. You can still escape. This leads to something remarkable. You could theoretically extract energy from a spinning black hole. Enter the ergosphere, throw something toward the black hole, and slingshot away with more energy than you entered with. The black hole would slow down slightly. Its rotational energy transferred to you. This is called the Penrose process. We've never done it, but the physics says it's possible. Black holes might power some of the brightest objects in the universe, quasars. A quasar is a galaxy with an extremely active, supermassive black hole at its center. The black hole is consuming matter rapidly. The accretion disk is enormous, blindingly bright. A single quasar can outshine its entire host galaxy. Trillions of stars, outshone by the glow of matter falling into darkness. Quasars are mostly found in the distant universe, because looking far away means looking back in time. Light from a quasar billions of light years away left that quasar billions of years ago. We see quasars as they were when the universe was young. Back then, galaxies were still forming. Black holes were growing rapidly. Quasars were common. Today, most nearby black holes have quieted down. They've consumed the easy matter around them. Now they wait. The black hole at the center of our galaxy is quiet now. Sagittarius, a star, 4 million solar masses, but not actively feeding, just waiting. Occasionally, a cloud of gas drifts too close. There's a brief flare of radiation, then silence again. Our black hole is sleeping, just like you soon will be. Some galaxies have two supermassive black holes. When galaxies collide, their central black holes eventually find each other. They orbit closer and closer over millions of years until they merge. We've found galaxies with black holes in the process of merging. Two bright points at the center, two accretion disks, spiraling toward their union. Our Milky Way will collide with the Andromeda Galaxy. In about 4 billion years, the two spiral galaxies will merge into one, and eventually, their central black holes will merge too. A new supermassive black hole at the heart of a new galaxy. We won't be here to see it, but the universe will continue. There's something peaceful about that thought. The universe will go on. Black holes will merge. Galaxies will evolve. Stars will be born and die. Long after we're gone, the cosmos continues. We're part of something much larger than ourselves. Let me tell you about the sounds of black holes. In 2022, NASA released audio of a black hole. Not gravitational waves this time, but actual sound waves. The black hole at the center of the Perseus galaxy cluster produces pressure waves in the hot gas around it. These are sound waves, but at frequencies far too low for humans to hear. Scientists shifted them up into the audible range. The result was eerie, a deep moaning sound. Like the groan of the cosmos itself, black holes sing in frequencies we can barely detect. The universe is full of hidden music. Gravitational waves are like bass notes from the largest instruments imaginable. Sound waves from black holes rippling through gas clouds. We're only beginning to hear the symphony. Black holes might help solve the mystery of dark matter. Dark matter is invisible. It doesn't emit light. We only know it exists because of its gravity. It holds galaxies together, but we don't know what it's made of. Some scientists have proposed that primordial black holes might be dark matter, tiny black holes formed in the early universe, drifting through space, contributing their gravity to galaxies. We haven't found evidence for this yet, but we're still looking. The universe keeps its secrets well. Black holes might be the key to a theory of everything. We have two great theories of physics. General relativity describes gravity and space-time. It works beautifully for large objects, planets, stars, galaxies. Quantum mechanics describes the behavior of tiny particles, atoms, electrons, photons. Both theories are incredibly successful, but they don't work together at a black hole singularity where huge mass meets tiny size. Both theories should apply, but they give contradictory answers. Solving this contradiction might lead to a unified theory, a theory of quantum gravity, a theory of everything. Black holes are where our understanding breaks down, and that's exactly why they're so valuable. The study of black holes has led to new ideas about entropy. Entropy is a measure of disorder. Everything in the universe tends toward greater entropy. Things fall apart. Order becomes disorder. Black holes have entropy, enormous entropy. In fact, the entropy of a black hole is proportional to its surface area, not its volume. This led to the holographic principle, the idea that all the information in a volume of space can be encoded on its boundary, like a hologram. This is one of the deepest ideas in modern physics, and it came from studying black holes. Black holes have temperature. This was another of Hawking's insights, because black holes emit Hawking radiation. They have a temperature. The smaller the black hole, the hotter it is. A stellar black hole has a temperature just above absolute zero, almost unmeasurably cold. But as a black hole evaporates and shrinks, it gets hotter. In its final moments, it would be incredibly hot. A brief flash of radiation, then nothing. No one has ever detected Hawking radiation directly. It's too faint. The radiation from a stellar black hole would be overwhelmed by the cosmic microwave background, the leftover glow from the Big Bang. But scientists are working on analog experiments, creating conditions that mimic black holes to test Hawking's predictions. The universe is patient, so are scientists. Black holes challenge our understanding of cause and effect. Inside a black hole, the normal flow of time breaks down. The singularity is not a place you can avoid by choosing a different path. It's a moment in your future. All paths lead to it. What does causality mean when the future is a place? We don't fully understand. Black holes push us to the limits of philosophy as well as physics. There may be a firewall at the event horizon. This is a controversial idea. Some physicists have suggested that the event horizon is not a gentle boundary, that there might be a wall of high-energy particles there, a firewall. If true, anything crossing the horizon would be destroyed instantly. But other physicists disagree. They argue the equivalence principle requires the horizon to be smooth. The debate continues. We may need to visit a black hole to find out. That won't happen anytime soon. Let me share something calming. Despite all their strangeness, black holes follow rules. They obey the laws of physics. General relativity, thermodynamics. They're not chaotic, not random. They're among the most orderly objects in the universe. 3 numbers describe a black hole completely. Mass, spin, charge. That's remarkable simplicity. In a universe full of complexity, black holes are paragons of order. And that order is beautiful. Einstein's equations describe black holes perfectly. The mathematics is elegant, symmetrical. Scientists often describe the equations as beautiful. Beauty in physics usually means truth. Black holes are not just strange, they're elegant. The study of black holes brings together all of physics: gravity, thermodynamics, quantum mechanics, electromagnetism. Everything comes together at a black hole. That's why physicists love studying them. They're a meeting place for all the fundamental forces, a laboratory for the deepest questions. And yet, black holes are also simple, a region of space where gravity dominates. That's all. No magic, no mysticism, just physics. Taken to its extreme, the universe created black holes as a natural consequence of its laws. Stars burn, stars die. Sometimes what remains is so dense that it collapses into a black hole. It's inevitable. Given enough mass, gravity wins. Black holes are not accidents. They're built into the fabric of reality, and you are also built into the fabric of reality. The same laws that govern black holes govern the atoms in your body. The same gravity that creates event horizons holds you gently to this earth. You and the black holes are part of the same universe, subject to the same laws, made of the same fundamental stuff. That's a wonderful thought. You're connected to the cosmos, not just metaphorically, physically. The iron in your blood was forged in a massive star, a star that may have become a black hole. You carry the legacy of stellar death in every cell of your body. The universe made black holes, and the universe made you. Both are remarkable, both are precious. As you drift towards sleep, carry that thought with you. You are part of something vast, ancient, ongoing. Black holes will continue existing long after tonight, and the matter that makes you will continue being part of the universe. Nothing is truly lost, just transformed. The night is deep now. The black holes are keeping their watch in the center of galaxies, in the spaces between stars, in the fabric of space-time itself, silent, patient, real, and you are right where you belong, safe on this planet, warm in your bed, ready for sleep. Let the universe hold you. Let the darkness be peaceful. Let your thoughts drift like light toward a distant horizon. There's nothing to fear in the dark, only rest, only quiet, only peace. Good night. May your sleep be deep and untroubled. May you dream of stars and galaxies, and may you wake, rested and renewed, ready for another day in this remarkable universe. But before you go, let me share a few more gentle thoughts. Black holes are not alone in the universe. They exist alongside stars, planets, nebulae, galaxies. The cosmos is rich with wonders. Black holes are just one chapter in an endless book. Think of all the things we've discovered in just the last century. Black holes, the expansion of the universe, dark matter and dark energy, exoplanets orbiting distant stars, gravitational waves rippling through space-time. Each discovery opens new questions, new mysteries, new wonders. The universe is generous with its secrets if we're patient enough to listen. Scientists estimate there are 2 trillion galaxies in the observable universe. 2 trillion, each one containing billions of stars and possibly millions of black holes. The numbers are beyond imagination. And yet, here you are, on one small planet, around one ordinary star, in one spiral galaxy among trillions. Thinking about it all, that's remarkable. Consciousness is one of the universe's greatest mysteries. We don't know why matter became aware of itself, why atoms arrange themselves into beings that could wonder, But they did, and here you are, the universe contemplating itself. Through your eyes, the cosmos sees black holes. Through your mind, the cosmos asks questions. You are how the universe knows itself. That thought can feel heavy, or it can feel light. Let it feel light tonight. You don't have to carry the weight of existence. Just rest in the wonder of it. Black holes will continue, whether you think about them or not. Stars will burn. Galaxies will spin. Time will flow. The universe doesn't need your attention to keep going, so let your attention rest. Let your thoughts grow quiet. Let sleep come naturally. There's a black hole out there, right now, consuming a wisp of gas. The gas spirals inward, heats up, glows briefly, then vanishes beyond the event horizon. No one is watching. No one needs to. It just happens, quietly, in the dark between stars. There's a black hole out there, right now, orbiting another black hole. They spiral closer, decade by decade, century by century. In 1,000,000 years, they'll merge, send gravitational waves rippling across the cosmos, and no one will notice because it's happening in empty space, far from any planet. The universe is full of events we'll never see. That's okay. There's a black hole out there, right now, that formed from a star that shone before Earth existed. Ancient light once warmed planets we'll never know about. Life might have evolved and died. Civilizations might have risen and fallen, all before that star collapsed. And now it's a black hole, silent, carrying no memory of what came before, except perhaps in the quantum information encoded on its surface. Perhaps. We don't know. There's so much we don't know. And that's beautiful. A universe we fully understood would have no more surprises, no more discoveries, no more wonder. The unknown is not frightening. It's an invitation to keep asking, keep learning, keep wondering, but not tonight. Tonight is for rest. The questions will wait. Black holes will wait. The universe will wait. Let your body sink deeper into comfort. Let your breathing slow to its natural rhythm. Let your mind release its hold on thoughts. Imagine yourself floating in space, not near any black hole, just drifting in the gentle emptiness between stars. No gravity pulling you anywhere. No urgency. No destination. Just peace. Just stillness. Just being. The stars are distant points of light, billions of them. Each one a sun. Each one warming its own planets. You're surrounded by light. Ancient light that has traveled for years to reach you. Some of those stars have already died. Their light is all that remains, a memory crossing the void. And somewhere out there, hidden in the darkness, black holes are waiting, not threatening, just existing, part of the cosmic landscape, as natural as mountains, as inevitable as rivers. They belong here, and so do you. The universe made room for everything, for stars and planets, for black holes and nebulae, for gas clouds and galaxies, for atoms and molecules, for life and consciousness, For you, there is room for you in this universe. You belong. Let that thought be a blanket, wrapping around you, keeping you warm, keeping you safe. You belong. The same forces that shape black holes shaped you. Gravity held the cloud of gas together that became our solar system. The same gravity that creates event horizons pulled Earth into a sphere, keeps the moon in orbit, keeps you grounded. Gravity is not your enemy. It's what makes home possible. And even black holes, those extreme expressions of gravity, are not enemies. They're just nature being nature, physics being physics, the universe following its own rules. There's no malice in a black hole, no intention, just existence. In some ways, black holes are the most peaceful places in the universe. Beyond the event horizon, nothing changes, nothing escapes, nothing disturbs the silence, pure stillness, the ultimate rest. Not that you want to go there, but you can appreciate the concept, a place of absolute quiet, absolute peace, no light to disturb, no sound to intrude, just darkness and stillness and eternity. Your bedroom is not a black hole, but it can be a place of peace, a place where the noise of the day fades away, where thoughts slow down, where sleep comes naturally, your own personal event horizon, between waking and dreaming. Cross that horizon now. Let go of the day. Let go of tomorrow's worries. Just be here. Just be now. Just be. The black holes don't worry about the future. They have no sense of time. For them, every moment is the same moment, eternal and unchanging. You don't need to be eternal, but you can borrow their peace just for tonight. Tomorrow will bring new thoughts, new challenges, new wonders, but tomorrow is not here yet. Right now, there is only rest. The universe will continue while you sleep. Stars will burn, planets will orbit, black holes will spin, galaxies will drift apart. None of it needs your attention. Right now, let the cosmos take care of itself. You've done enough for today. When you wake, the universe will still be here, full of mysteries, full of wonders, full of black holes, waiting for you to wonder again. But first, sleep, deep, restful, peaceful sleep, the kind of sleep that restores, that heals, that prepares you for another day of living. You deserve this rest. You've earned it. Let go now. Let the darkness be soft. Let the silence be comfortable. Let sleep take you gently. Good night. Sweet dreams. And thank you for wondering about black holes with me tonight. The universe is a little less lonely when someone is paying attention. The night continues, stars shine, black holes spin, the cosmos unfolds, and you rest, part of it all, safe and warm, at peace. Did you know that black holes can sing? In a way, the pressure waves they create in surrounding gas have frequencies. The black hole in the Perseus galaxy cluster produces a note 57 octaves below middle C, far too low for human ears, but real, a cosmic hum. Imagine the universe humming to itself, a deep bass note resonating through clouds of hot gas. Music no one can hear, but everyone is part of. You're part of that music too. Every atom in your body vibrates at frequencies we can't perceive. You are a symphony of particles dancing to the quantum laws. The same laws that govern black holes govern the electrons in your brain. Right now, as you drift towards sleep, tiny particles are doing their quantum dance, creating thoughts, creating dreams, creating you. It's a miracle, really, that matter can think, that atoms can dream, that the universe can wonder about itself. And tonight, you're doing all of that, thinking about black holes, dreaming of the cosmos, wondering, what a gift. Let that gift settle into gratitude. Gratitude for this moment, this breath, this awareness. Even as it fades into sleep, it's precious. Black holes will never know they exist. They have no consciousness, no awareness, no sense of wonder, but you do. You can look up at the stars and feel something. Awe, curiosity, peace. That's something a black hole will never experience. In that way, you're richer than any black hole. Consciousness is rare in the universe, as far as we know. Most of the cosmos is empty space, vacuum, nothing. Stars are rare islands in the void. Planets are rare companions to stars. Life is rare on planets. Consciousness is rare in life. You are rare, precious, unique. The universe spent 14 billion years getting to this moment. Galaxies formed, stars ignited, planets coalesced, life emerged, evolved, became aware, and here you are, the latest chapter in a 14 billion year story. Black holes are part of that story too. They formed from the deaths of massive stars, stars that made the heavy elements, elements that became planets, and life, and you. Without stellar death, there would be no black holes, and no you. The same cosmic cycle that creates the darkest objects in the universe also created the light of consciousness, death and life, darkness and awareness, all part of the same story. That's something to rest in. You're not separate from the cosmos. You're an expression of it. When you wonder about black holes, the universe is wondering about itself. When you dream, the cosmos dreams. So dream well tonight. Dream of distant galaxies. Dream of spinning black holes. Dream of gravitational waves rippling through space-time. Or dream of nothing at all. Whatever your sleeping mind creates is part of the universe too. The night is quiet now. Outside your window, the stars are shining. You can't see them all, but they're there. And beyond them, more stars, more galaxies, more black holes, an infinite vista of wonder, all of it continuing. While you sleep, you don't need to watch over the universe. It manages itself, has been for 14 billion years, will be for trillions more. Your job tonight is simply to rest. Let the black holes do their thing, bending light, warping time, consuming matter, spinning in the dark. They don't need your help. They don't need anyone's help. They just are. And you just are, lying here, breathing slowly, resting deeply, being. That's enough. That's everything. The universe doesn't ask you to be more than you are. It doesn't ask you to understand everything, or solve every mystery, or stay awake forever. It just asks you to be, and you're doing that perfectly. So rest now. Rest completely. Let the darkness enfold you like a blanket. Let the silence hum like a distant black hole. Let sleep take you where it will. You are safe. You are held. You are home. Let me leave you with a few more peaceful images. As your mind drifts toward dreams, picture a black hole at the center of a distant galaxy, millions of light years away. Around it, a swirling disk of gas and dust, glowing with soft light. The disk rotates slowly, peacefully. Matter spirals inward, but there's no rush. The black hole has infinite patience. It has waited billions of years. It will wait billions more. Imagine the view from a planet in that galaxy. Looking up at the night sky, you might see the glow of the accretion disk, a soft light at the center of the galaxy. Not frightening, just there, part of the cosmic landscape, as familiar as the moon is to us. Or picture a binary black hole system, two black holes orbiting each other. They've been dancing for millions of years, slowly spiraling closer. Their dance sends ripples through space-time, gentle waves propagating outward. No sound, no light, just the fabric of the universe quietly vibrating, a cosmic waltz. Somewhere in the universe right now, two black holes are merging, their event horizons touching, combining, becoming one, a burst of gravitational energy rippling outward at the speed of light. In a billion years, those waves might reach Earth, and our descendants might detect them. A message from an ancient collision. The universe is full of such messages. Light from ancient stars, gravitational waves from distant mergers, cosmic rays from supernova explosions, all of it traveling through space, crossing the void, carrying stories from the past. You're bathed in these messages right now. Ancient photons passing through your room, gravitational waves stretching and compressing space by amounts too tiny to feel. The universe is constantly communicating. We're just learning to listen. Black holes are part of that conversation. They speak through gravity, through the light they bend, through the waves they create when they collide, and we've started to hear them. That's remarkable. 100 years ago, we weren't sure black holes existed. 50 years ago, we had hints, but no proof. Today, we have photographs. We have recordings of their mergers. We understand their physics. In just a few generations, we went from imagination to observation. That's the power of human curiosity. And your curiosity tonight is part of that tradition. By wondering about black holes, you're participating in humanity's greatest adventure, the adventure of understanding. but adventures need rest. Even explorers need sleep. So let your wondering settle now. Let it become a gentle hum in the background, a lullaby of cosmic questions. The answers will still be there tomorrow. Black holes will still be spinning. Galaxies will still be drifting. Scientists will still be searching. Nothing will be lost by sleeping. Everything will be gained by resting. Your body knows how to sleep. You don't need to figure it out. Just let go, and it will happen. Like gravity, natural, inevitable. Let go now. Feel the weight of your body sinking into the bed. Feel the rhythm of your breath slowing naturally. Feel the warmth of rest spreading through you. The universe is vast, and you are small, but smallness is not insignificance. You are a point of awareness in a cosmos that is mostly unaware, that makes you precious. Black holes contain the mass of millions of suns, but they cannot think, cannot feel, cannot wonder. You can. In the currency of consciousness, you are richer than any black hole. In the economy of wonder, you are a billionaire. Spend that wealth wisely. Wonder often. Ask questions. Appreciate the mystery. And rest when you need to rest. Tonight is for resting. The black holes will keep their secrets a little longer. The universe will continue its expansion. Stars will burn. Planets will turn. Galaxies will evolve. And you will sleep peacefully, deeply, completely. When morning comes, you'll wake refreshed. The sun will rise, just as it has for billions of years, and the world will be waiting, full of possibilities, full of questions, full of wonder. But that's for tomorrow. Right now, there is only this moment, this breath, this rest, this peace. Let it fill you. Let it carry you. Let it guide you into dreams. The universe is dreaming through you. What will it dream tonight? Black holes and distant galaxies. Stars being born in clouds of gas. Light bending around invisible masses, or something entirely different. It doesn't matter. Whatever you dream is part of the cosmic story. Sleep well, dream well, and know that you are part of something beautiful, something vast, something ancient, something ongoing. The universe is glad you're here. Even if it can't say so, I can. Thank you for being here tonight. Thank you for wondering. Thank you for listening. Before you drift away completely, let me share a few more wonders, soft thoughts, to carry you into sleep. Did you know that light cannot escape a black hole, but gravitational influence can? The gravity of a black hole reaches across space, affecting stars, bending light from distant galaxies. Even though nothing escapes the event horizon, the black hole's presence is felt far beyond. Like a stone dropped in a pond, the ripples spread outward. Black holes are connected to everything around them, and in a way, so are you. Your gravity, as small as it is, reaches out into the universe. You're pulling on distant stars right now. by an amount too tiny to measure, but real. You're part of the gravitational web that holds the cosmos together. Every object with mass curves space-time. You curve space-time. Just a little, but you do. Einstein would say, you're telling space how to curve, and space is telling objects around you how to move. It's a beautiful dance. The same dance black holes do, just at a much grander scale. When you lie very still, you can almost feel the earth rotating beneath you, spinning at 1,000 miles per hour, while orbiting the sun at 67,000 miles per hour, while the sun orbits the galaxy at nearly 500,000 miles per hour, while the galaxy itself drifts through the universe towards some unknown destination. You're never truly still. You're always moving, always part of the cosmic flow. And at the center of our galaxy, Sagittarius, a star, sits. 4 million solar masses, spinning slowly, waiting. Everything in the galaxy orbits around it, including you. You're on a 230 million year journey around the galactic center. We've made this trip about 20 times since the Earth formed, 20 galactic years. The dinosaurs lived during a different galactic position. The stars in the sky were in different places. The night looked different. But the black hole at the center was already there, watching, waiting, anchoring the galaxy. It will still be there, long after humans are gone, unless the galaxy merges with another, and the black holes combine, creating something even larger. The universe recycles everything, even black holes. Nothing is wasted in the cosmos. Matter becomes energy. Energy becomes matter. Stars become black holes. Black holes become radiation. Everything transforms. Nothing disappears entirely. You are part of that transformation. The atoms in your body have been many things. Part of ancient stars, part of cosmic dust, part of the earth, part of countless other living things. And after you, they'll be part of something else. The universe borrows atoms and returns them for the next creation. That's not sad. It's beautiful. You're part of an eternal recycling, a cosmic dance of matter and energy. For this brief moment, those atoms are you. What a gift. Black holes participate in this dance too. They seem to consume everything, but through Hawking radiation, they eventually return it, over timescales beyond imagination. But eventually, nothing is truly lost, not even in a black hole. The information that falls in somehow comes back out. We don't fully understand how, but the math suggests it does. The universe keeps its books balanced, and tonight, your consciousness will transform too. Waking awareness will become dreams. Active thought will become rest. The mind will quiet, and something else will emerge. Sleep is its own kind of transformation, necessary, natural, healthy. Let it happen now. The black holes are patient. They don't mind waiting for you to fall asleep. They've waited billions of years already. What's a few more minutes? Take your time. Let sleep come at its own pace. There's no deadline for rest, no alarm clock for dreams. Just let go, bit by bit, thought by thought, breath by breath. The universe will catch you. It always does. And when you wake, the black holes will still be there, still spinning, still bending light, still keeping their secrets. And you'll have new energy, new curiosity, new questions. But for now, just rest. The cosmos will take care of itself. Good night, sweet dreams, and may the darkness be kind to you. One last thought before you go. In all the vastness of the universe, with all its black holes and galaxies, its stars and planets, its mysteries and wonders, there is only one you, one consciousness experiencing this moment, one mind wondering about black holes, one heart beating in this room. The universe is 14 billion years old. It will continue for trillions more, and in all that time, there will only ever be one you. This moment is unique. This night is unique. You are unique. That's worth appreciating, not with pride, not with anxiety, just with gentle awareness. You are here. You are real. You matter. Black holes will never know they exist. Stars will never appreciate their own light. Galaxies will never marvel at their own beauty. But you can. You have the capacity for wonder, for appreciation, for love. That's extraordinary. In a universe of unconscious matter, you are a point of awareness, a candle in the cosmic dark, small but real. And tonight, that candle can rest. The flame can flicker low. Sleep can come, because tomorrow, the candle will burn again, bright and curious, ready to wonder, ready to learn, ready to live. But not tonight. Tonight is for darkness, peaceful darkness, the kind of darkness that heals, that restores, that renews, like the darkness of space, but warmer, like the darkness inside a black hole, but gentler. Your own personal darkness, soft, safe, welcoming. Enter it now. Let it embrace you. Let sleep carry you away to wherever dreams go, to whatever rest awaits. The universe will be here when you return. The black holes will be here. The stars will be here. Everything will be as it was, except you. You will be rested, renewed, ready. That's the gift of sleep. Accept it now. Gratefully, peacefully, completely. Good night. The night is deep. The universe is vast, and you are exactly where you need to be, resting, dreaming, at peace.